Hello friends, in this video we are going to see semiconductor materials, right? In particular we are going to see germanium and silicon. Okay, these are the two semiconductor materials which are most widely used today in the manufacturing of the ICs and a lot of more purposes. Okay, now first let us know why these two semiconductors are most widely used. The reason behind this is that these semiconductors can be purified to a very high purity level, near about 1 part in a 10 billion, means 1 part impurity in 10 billion parts. That level of purity is maintained can be achieved in germanium and silicon. As far as the structure goes, germanium and silicon have crystalline structure, right? Like this crystalline structure, and they have the tendency to repeat the structure after a certain interval of time. Means they had a crystalline structure and that too repeating. That case, the structure is called single crystal structure, which is constantly repeating itself. Okay, now if we see the atomic structure, this is for germanium, this is for silicon. These are the nucleus, these are the orbits, these are the orbits or cells, these are the orbiting electron, and these are the valence electrons. 1 2 3 4. In this case also 1 2 3 4, means both these semiconductors have 4 electrons in their outermost shell. That means they cannot actually give away their 4 electrons so easily, and there is very less elements that can give away their 4 electrons in the outermost shell. Basically, actually the stable case is 8 electrons. They have half of them. So the only bond they can form is a covalent bond. And what is a covalent bond? Covalent bond means they have to share the outermost electrons with other element of the same nature or different. Okay, so here you can see that a silicon atom can share its electron with another silicon atom, and that silicon atom share with another 4 silicon atoms. Means actually they form the covalent bond within their self. Okay, the covalent bond of silicon atom is here. Sharing electrons are these two. In case of these two atoms, if you see this atom, then these are the two sharing electrons between these two atoms, and these are the between these two atoms, these and this. Okay, these are the valence electrons of silicon. 1 2 3 4. In every case there are 4 electrons, valence electrons, which they are sharing with other silicon atom. Okay, now the next topic which we are going to discuss is intrinsic material. What is an intrinsic material? These semiconductors actually these are the semiconductors which are very pure, means a very less impurities are found in these materials. These are called the intrinsic semiconductors, means near about as much pure as can be achieved. At room temperature, intrinsic silicon have 1.5 into 10 to the power 10 electrons per cubic centimeter. These are the free electrons which is found in silicon, intrinsic silicon element per cubic centimeter at room temperature. In case of germanium, it is 2.5 into 10 to the power 13 electron, free electrons. Further, these number can vary according to the temperature. If temperature rises, the number of free electrons also rises, as semiconductors have the tendency to lose electrons on rising temperature. Means they have negative temperature coefficient. Okay, means their resistance decreases as the temperature increases. You can see in the context of free electrons as well. As the temperature increases, free electron increases, which will facilitate in conduction, that by decreasing resistance. In the case of conductor have positive temperature coefficient. That means if temperature increases, their resistance also increases. The main reason for that is their lattice vibration, which leads to the interruption in the flow of current, increasing the resistance with the rise in temperature. Okay friends, the next topic which we will discuss is extrinsic material. What is an extrinsic material? Extrinsic materials are those semiconductors which are subjected to doping. And what is doping? Doping means addition of some impurities in the form of other material into a pure material or any material which we are having focused on. If we add some external material in that material, the process is called doping. If we add some external material in our intrinsic semiconductor, the process is also called doping. And this is a very important process, as it will lead to the formation of N and P type semiconductors, which further lead to the formation of diode and all other devices based on N and P type, which is a very important topic. And from here, the actual topics of semiconductors devices begin. Okay friend, thank you for watching. Please do subscribe. Thank you. Have a nice day.